Hey everyone. We are moving on and we are starting with section 9.2 today, which is solving quadratic equations by graphing. So just as a quick reminder, we have previously solved quadratic equations by factoring. And now today we're going to use that factoring process in the way that we are going to start graphing. So first off, our essential question is, how can you use a graph to solve a quadratic equation in one variable? And then a quadratic equation, again, this is something that we've talked about a bunch. They're basically just saying that standard form for a quadratic is ax squared plus bx plus c, which again is something that we know. So I'm not going to spend any more time on it since I don't need to. Our core concept, first things first, whenever we are solving a quadratic equation by graphing, we always want to make sure that number one, this is the way we write the equation. They're going to try and throw some things at you where x squared may be on the other side, or maybe our b term is over on the other side. So you are always going to have to make sure that ax squared plus bx plus c, that all of your terms are on one side of the equation. Doesn't matter if it's the left-hand side, doesn't matter if it's the right-hand side, it's totally up to you which side you want it to be on. We're more familiar and more comfortable when it's on the left-hand side, but if you put it on the right-hand side, totally cool. Step 2 says graph the related function as y equals ax squared plus bx plus c. So you guys, we're basically just taking this and we're graphing it. I'm really honestly open if you want to factor to help you solve, or I think the general idea is that they want you guys to use more of like a table, an XY table. But honestly, I really don't think it makes a difference. It's totally up to you guys. Whatever makes the most sense for you when it comes to graphing. Maybe you're not super comfortable with factoring yet. Maybe I don't know. Anyway, doesn't really matter to me. I'll probably show both ways just so that we get better. And then step 3 says, and this is really the big part, this is the real reason we're doing this, find the x-intercepts. And I like this little section back here. It says, if any. You might not have any x-intercepts. Okay, your graph might end up being somewhere up here, which means that you don't have any x-intercepts. Okay, that graph's starting to move around a little bit. We just have to be able to identify where. And so we just want to make sure that we are getting those, we're finding those x-intercepts. Okay, so let's jump into our first example. Solve x squared plus 2x equals 3 by graphing. Okay, so first thing that you guys may notice is they, right off the bat, throw one at you that doesn't have everything on the same side. So we have to just start by making sure that we get everything on the same side. So we've got x squared plus 2x minus 3 equals 0. Okay, so then I think technically what they want you to be able to say is y equals x squared plus 2x minus 3. This is, remember, we talked about how if it's y equals, we know that we have to graph it. It's the graph of, or it's the equation of something that we can graph. We're dealing with a quadratic, so remember, whenever it's in standard form, we use the formula of opposite b over 2a to help us find the vertex. So let's just do that opposite of 2 over 2 times 1. So that will give us -1. And then in order for us to find the rest of the vertex, we have to take that -1 and we have to plug it in. So -1 squared plus 2 times -1 minus 3, and that will end up giving us, okay, so that's 1 minus 2 minus 3. That will give us -4. Okay, so our vertex is at -1, -4. So negative 1, 1, 2, 3, negative 4. Okay, so there's the axis of symmetry. And then we can do the y-intercept. So remember, our C term is always our y-intercept. So we can graph that. We know through symmetry that this point right here exists. But really, you guys, our goal is to try and find the x-intercepts. Okay, that's the entire reasoning behind this. So maybe from here, we have to try plugging 1 in. Okay, so if I plug 1 in, 1 squared plus 2 times 1, I don't know what I just did there. And then we just do minus 3. Okay, so 1 squared, that'd just be 1 plus 2 minus 3. Okay, that's going to give us 0. So here is one of our x-intercepts. X equals 1. And then again, you guys, just through symmetry, this is 2 to the right, 2 to the left. So x equals negative 3. Boom, boom. Those are our 2 x-intercepts, and that's what you're going to be asked to find a lot. So realistically, you guys, I'm kind of looking at these next 3 examples that you are going to be asked to do because they're exactly like this first example. Very, very similar types of problems. Find your vertex and then use symmetry to your advantage. If you really, really need to, then you can work on some factoring if you want to, but just working on your graphing of quadratics. All right, the next type of example that we have coming our way. Again, as you notice, this is not in our standard form, so we're going to have to start by getting it into standard form. So we've got to add 16 to both sides. So we've got x squared minus 8x minus 16. Sorry, that should be plus 16 equals 0. Graphing form is just this x squared minus 8x plus 16. All right, so here we basically, again, just want to make sure that we can find all of the pieces. Let's find the axis of symmetry. So opposite b, so opposite of negative 8 over 2 times 1. So your axis of symmetry is going to be x equals 4. Okay, so I'm going to start by doing that. 1, 2, 3, 4. Okay, here's axis of symmetry. And then let's take that 4 and let's plug it in. So you've got 4 squared minus 8 times 4 plus 16. Okay, so 16 minus 32 plus 16. Okay, this is going to give us 0. All right, so good. Our vertex then, ladies and gentlemen, is going to be at 4, 0. So we're going to plot this point right here. And then, I mean, let's just pick one point to the, well, I guess the other thing we could do is we can just find the y-intercept. So let's just kind of adjust this scale to our advantage. Let's say that this is 2, so that'll be 4, 6, 8, 10, 12, 14, 16. So we can just go ahead and say, okay, well, this is going to be our intercept, and then 1, 2, 3 over 4. So there's our graph. Okay, but this time, this point falls on the x-axis, so we only have one solution, and that one solution is just going to be at x equals 4. Okay, and that's really all they want you to do for that one. Next example, again, they give you a problem where x is not on the same side, so let's just get x squared over to the other side. Sorry, those are both supposed to be x's. So we'll just say, I'm going to kind of jump the gun here. I'm going to say y equals x squared plus 2x plus 4. Okay, so now let's try and find this axis of symmetry. So x equals opposite b over 2a. So our axis of symmetry is going to be x equals -1. Okay. So let's graph that really quick. And then let's plug -1 in. So -1 squared plus 2 times -1 plus 4. Let's see, that's 1 minus 2 plus 4. So that should give us what, 3? Okay, so our vertex is at -1, 3. 1, 2, 3. Our y-intercept is going to be up here at 4. Okay, so this time we end up having, because this doesn't ever cross this axis here, this x-axis, we don't have any solutions. So no solutions. And there we go. All right, you guys, I am done. Those are our 3 examples. Your job is to go ahead and do 1, 2, 3 on the first page of the 9-2 notes, and then 4 through 9 on the second page of the notes. All right, have a good night. I'll see you soon.